This lesson is going to be on arithmetic sequences, and so I've labeled it sequences and equations. So let's look here. First, before we show you what this is, I'm going to have you hopefully understand where this equation that we're going to look at comes from. So if I ask you to count by fives up to 40, I know that you could do that. You would go 5, 10, 15, 20, 25, 30, 35, 40. But what if I ask you to count by fives, but not to start on 5, but for example to start on 3? Could you start on 3 and count by fives? 3, 8, 13, 18, 23, 28, and so forth. That is an arithmetic sequence. It's where you are counting by the same number each time, but you may not be starting on the number that you are counting by. So here it is counting by this. So let's look at this. What we're going to have is a pattern of numbers here. So if we have the numbers 6, 7, 8, 9, and I ask you, for example, what would be, if I were to continue that pattern out, what would be the 15th term of that pattern? Well, you could sit here and count. Well, this is the first, this is the second, the third, the fourth, the fifth would be 10, the sixth would be 11, and so forth. And you could sit there and figure it out by doing that way. What we're going to do is learn an equation that you can use to figure out the certain term number, like if you want to find the 45th term of that sequence. How can I do that easily without having to actually count up that many times? So here's what we're going to do. Here's our sequence. We have 6 to 7, 7 to 8, 8 to 9. The first thing you're going to ask yourself is, what are you counting by? How much is it going up each time? Now, for this to be an arithmetic sequence, it has to be adding or subtracting the same number each time. So when we check this, we see that by each time it's going up by a positive 1. That's called the common difference. That's the first question you're going to ask yourself and figure out. Is it going up or down by the same number each time? And if it is, what is that number? The second question you're going to ask yourself is, did you start counting on that number? We said we were counting by 1, but did we start counting on the number 1? Did we say 1, 2, 3, 4? We did not. So we have to, if you did not start on that number, you have to say, how far away is the number you started on? I'm counting by ones, but I started on 6. 6 is 5 more than what I was counting by. Now with this 2 bits of information, we're going to write in our equation. So what we're going to do is we're going to write an equation that starts like this. You're going to put the term number is, you're going to have a number that you plug in here, and then you're going to have something that you plug in here. First of all, the first question is, what are you counting by? We were counting by ones. So the first part of the equation is going to be 1 times n, or 2 times n if you're counting by 2's, or 3 times n. Then, since we did not start counting on ones, but we started on a number that was 5 more, at the end of the equation we're going to add 5. So if we said, okay, what's the first number of the sequence? If we plugged in a 1 right here, well, the first number of the sequence is 1 plus 5, which is 6, as we saw right here. This was the first number of the sequence. Well, what is the second number of the sequence? If we plugged in a 2 to this equation, 1 times 2 plus 5, we would see that the second number is 7, which is what we had. So this equation allows us to say, okay, now what if I wanted to know what the 20th term of the sequence would be? Then I would plug in 20 to n. Okay, what's the 20th number of the sequence? 1 times 20 is 20 plus 5 is 25. So I can figure out any of the numbers by using this equation. This particular one says find the 12th term. So we plug in 12 to n, and you just have 12 plus 5. So the 12th term would be 17. So that's a little confusing at first if you haven't done this, but basically you're going to be asking yourself these 2 questions. first question is what am I counting by? When you figure out what you're counting by, you are going to put that number right here in front of the n. Then you're going to ask yourself, did I start counting on that number? If not, how far away was it? That's what you're going to put at the end of the equation. So let's look at another example. Here we have a sequence of 4, 8, 12, 16. This just means that this is the first number of the sequence, the second number of the sequence, third and fourth number. Okay, first question, what are you counting by? I am going a positive, I'm adding 4 each time. You have to be adding or subtracting the same number each time for it to be an arithmetic sequence. This is, what am I counting by? I'm counting by 4, so I'm going 4, 8, 12, 16. Second question, did I start counting on that number? I'm counting by 4s, but did I start counting on 4? Well, on this one, I actually did. So we didn't have to put that part of the equation in. Okay, so remember, we start with t equals something times n. What are we counting by? 4. And we started on 4, so we don't need this part of the equation. Now to find the 20th term, all we have to do is plug in 20 to n, and 20 times n would be 80. So that would be the 80th. 80 would be the 20th term of that number. Now if you use this equation, then you don't have to sit there and count by 4 20 times to find the answer. Let's try another one. Okay, this just means this is the first number in the sequence, this is the second number, the third number, the fourth number. So don't worry about these numbers. But what am I counting by? Here I have a sequence. This is going plus 3, plus 3, plus 3. It is an arithmetic sequence because I'm adding or subtracting the number. So when I start writing my equation, I'm counting by 3, so I'm going to put 3 in front of the n. My second question would be, did I start counting on that number? The number was 3. I'm counting by 3s. Did I start counting on 3? I did not. I started on 7. And 7 is 4 more than 3, so I'm going to add 4 for the 4 more. So it's like counting by 3s, but I didn't start on 3. I started on 7, which was 4 more. So now to find the 15th term, I simply plug in 15 to n, and I go 3 times 15, which is 45. And then I'm going to add that 4. That would have been what the number was had I started counting on 3. But I didn't start counting on 3, so now I have to add 4 to shift it over 4 places to 49. So 2 questions. What am I counting by? Here's the sequence. What am I counting by? Each time I am going up by 11. So I'm counting by 11s. So for my equation, I write 11 times n. Did I start counting on 11? Well, in this one I did. So I don't need the second part of the equation. Now to find the 25th term, I simply plug in 25 to n, and I ask myself, what is 11 times 25? And that is 275. Okay, here's another sequence. We have 7, 10, 13, 16. Each time we're going up by 3. My first question, what are we counting by? We're counting by 3s. So with my equation, I write t equals 3n. Second question, did I start counting on 3? No, I started on a number that was 4 more, because 7 is 4 more. So there's my equation. And then when asking for the 20th term, we would plug 20 in. 3 times 20 is 60, and 60 plus 4 is 64. Okay, this one's on your notes. What am I counting by is your first question. If you look here, each time I'm going up by 4, so I'm counting by 4s. So when I write my equation, I start with t equals 4 times n. Second question, did I start counting on 4? No, I started on 1. 1 is 3 less than 4, so I have to put a minus 3. I didn't start counting on 4 by 4 and go 4, 8, 12. I'm counting by 4s, but I actually started on 1, which is 3 less. So I have to subtract 3 at the end of my equation. So here's my equation, 4n minus 3. And then to find the 89th term, all I have to do is plug in 89 to n. And 89 times 4 would be, minus 3 would be 353. Two questions. What am I counting by? And did I start counting on that number? I hope this helps you with arithmetic sequences.